Okay, so in today's video we're going to have a look at completing the square and also solving with using completing the square as well. So we're going to have a look at answering particular questions like the one on the screen, but we've got a few things to look at before we actually get to this type of question. So throughout the video I'm going to assume that you already know how to complete the square where there are coefficients that are not bigger than 1. So I'll link that video in the description. Obviously check that one out first if you haven't already, but we're going to get started and have a look at some of these slightly harder completing the square questions. Okay, so we're going to start with one of these questions here. So grab a piece of paper, grab a pen, make some notes, and we'll have a look at how we go about answering one of these questions. So as I said, we are going to have the assumption throughout this video that you already know how to complete the square, and we're just going to have a look at these slightly harder questions where we have coefficients of x squared that are bigger than 1. So when it comes to this question here, obviously this is what we're going to complete the square for, and we're going to find the turning point to start with and have a look at how we apply it for that as well. So when we've got this one here, now this is our quadratic that we have at the moment, 2x squared plus 16x plus 26. Now we can only complete the square, well I say we can only, we have to get the coefficient of x squared to be 1 first before going about completing the square. So what we're going to do is we're going to factorise it by a factor of 2, okay? So that as they all divide by 2 there, or just because x squared has a 2 in front of it, we're going to take a factor of 2 out. So if I factorise this by 2, I get 2 lots of, and then dividing everything by 2, we get the 1x squared, we get 8x, and we get 13 at the end. There we go. Now all I'm going to do is I'm going to basically ignore that 2 is at the front. So all I'm going to do is factorise or complete the square for what's in the middle here. Okay. Obviously we've factorised it there, we've taken out a factor of 2, and now we're going to complete the square for what's inside. So normal process for completing the square, I am going to halve the coefficient of x. So in my bracket I'm going to have x plus 4, obviously halving the 8 there, and that is going to be squared. Obviously remembering why we do that, because when we expand that we get the x squared, we get the 8x, but at the end if we expand it we'd get plus 16. Now we don't want plus 16, we want the plus 13 there, so we're going to have to take away 3 to make this balance out. So I will have to put minus 3 at the end. And now if I did expand and simplify all of that, I would get the x squared plus 8x, I'd get plus 16, take away the 3, and that'd leave me with the 13 that I'm looking for. Now obviously we can't forget that 2 exists, that 2 is still at the front there, and we have to bring that 2 back in. Now what I'm going to do is I'm going to put all of this in a bracket, and rather than using a rounded bracket, I'm going to put it in a square bracket just to define, obviously it's a different set of brackets there, and I'm just going to put that 2 back at the front. Right, there we go, well we're almost done. All I've got to do now is reintroduce that 2, and that just means expanding out this square bracket by that 2. And that's easy enough to do. We've got 2 lots of the bracket there, so I'm just going to write this out. Let's see what we've got. We've got 2 lots of the x plus 4 squared. There we go. And then timesing that negative 3 by 2 will leave us with negative 6. And there we go, that's that completed in completed square form. All we have to do now is obviously, like before, we identify the turning point from what's in the bracket there. So just like before, the x coordinate is right here, but we flip the sign. So that is going to be negative 4 as our x coordinate, and our y coordinate is just at the end there, the minus 6. So there we go, our y coordinate is minus 6. There we go, and that's the coordinates of our turning point. So very, very similar to obviously normal completing the square, but obviously we just have this extra element there of factorising out that coefficient of x squared and then reintroducing it at the end and just multiplying that number at the end there, that what was normally our y-intercept, or I'm sorry, our y coordinate, and actually just multiplying that back out by the factor that we took out at the start. So there we go, that's how we're going to go about these questions. Obviously there are different wordings that you can have for these questions as well, and we're going to have a look at a slightly different worded question but following the same process. So let's have a look at that one now. Okay, so we've got a very similar question here, and again we have a 2 in front of our x squared, so we're going to have to factorise a 2 out as well. But it says write out this quadratic in the form a brackets x plus b squared plus c. Now obviously it doesn't say to complete the square, but that there is in completed square form, and it's all about having to recognise that this means complete the square. It says a, b and c are integers, just meaning they're whole numbers, but it doesn't actually specifically tell us to complete the square. We just have to recognise it and know that obviously when we complete the square that's what our answer is going to look like. And it says here, hence find the coordinates of the turning point, okay, for that graph. So first of all we're going to go about completing the square, and just like before I'm just going to factorise out this 2. but something slightly different is going to happen in this one. And it shouldn't really put us off, but if you have a look, that number at the end, that 23, obviously doesn't divide perfectly by 2 to make a whole number, so we are going to have some decimals involved here. So when I take that 2 out, let's have a look what we get. So we get 2 lots of, and we have x squared, negative 12 divided by 2 is negative 6x, and then 23 divided by 2 is 11.5, so plus 11.5. Right, there we go. So we've divided it by 2. Now we just need to complete the square for what's in here. So if we complete the square for that, again, we're going to halve that coefficient of x. So in our bracket, we'll have x minus 3 squared. And when we expand that, we would get plus 9 at the end. Now, obviously, we don't want plus 9. We want 11.5. So I need to add, let's have a look, an extra 2.5 to that. So that'd be plus 2.5. Right, there we go. So that is in completed square form. Obviously now we just need to reintroduce that 2. Now if I bring that back to the start, and again I'll put it in a squared bracket, and let's get the 2 back at the start, and then let's just expand that out and finish this off. There we go. So we have 2 lots of the bracket, so 2 lots of x minus 3 squared, and then 2 lots of the 2.5, which gives us plus 5 at the end. And then again we just read the coordinates of our turning point from that. We've got the normal x coordinate in here, which flips again, so we have minus 3 turns into positive 3, and then we have the 5 at the end, and that's a positive 5, so our y coordinate is positive 5. And there we go, there's our final answer. 3, 5 is our turning point. So before we start having a look at solving using completing the square, I'm going to get you to have a go at a couple of questions, so here they are. Okay, so there's 2 questions. Just watch out for that first one because it is a 3x squared, so you're going to have to factorise by 3 to start with. But pause the video there, have a go at these 2, and we'll go over the answers in a sec. Okay, so for this first one then, we've factorised 3 out to start with. So if we take 3 out, inside we get x squared minus 6x plus 2. And then just like normal, we'll go about completing the square for what's inside here. So halving the coefficient of x, we get x minus 3. Squared, that would give us plus 9 at the end, and we want plus 2, so we're going to have to take away 7. Reintroducing that 3 then from the start, so let's put that 3 back in and times this out, and we end up with 3 lots of x minus 3 squared, and then negative 7 times 3 is negative 21. And then again we just read the numbers, so we have minus 3, which can then flip to positive 3, and negative 21 at the end, and that symbol stays the same. So our coordinates of our turning point are positive 3, negative 21, and there's our final answer for that first one. Let's just highlight that. On to our next one. Following the same process, we're going to factorise 2 out, so we have 2 lots of, and we have x squared minus 4x, and 7 divided by 2 is 3.5, so there we go, we've got a decimal involved in this one. And again, completing the square for what's inside, halving that coefficient of x, we get x minus 2 in brackets squared. That would give us plus 4 at the end. We want plus 3.5, so we're going to have to take away 0.5 or a half. There we go. And then again, just reintroduce that 2, and we'll multiply that out. So when we times that out, we get 2 lots of the x minus 2 squared, and then a half times by 2 is going to be minus 1. Right, there we go. So again, reading the coordinates there, we've got negative 2 in the bracket and negative 1 at the end. So the negative 2 flips to become positive 2, and at the end we have minus 1. So there are the coordinates of our turning points. Right, okay, so we're going to come away from coordinates of turning points. We're going to have a look at how we go about solving using this process as well. And let's have a look at that. So when it comes to solving using completing the square, this is essentially just another alternative to using the quadratic formula. So we tend to use this obviously for a quadratic that doesn't factorise, and obviously we'll be leaving our answer in surd form, which we'll have a read as we read through this question. So it says write x squared minus 10x plus 7 in the form x plus p squared plus q, where p and q are integers. Okay, so obviously just recognising that that's in completed square form. Now for the purpose of this first one, I've not picked one where there's a coefficient of x squared greater than 1, but we are going to have a look at that one next, but we'll have a look at the process on this one to start with. So it says hence solve this equation, x squared minus 10x plus 7 equals 0, giving your answer in the form a plus and minus b root 2, where a and b are integers. Now we are going to use a little bit of surds within this, so again you need to have a little bit of an understanding of simplifying surds. Again, I will link the video to simplifying surds in the description, but the surds element of this is quite simple surds. So obviously just check that out if you haven't already, but we're going to have a look at how we go about answering this question. So for the first part, obviously it says write it in completed square form. Obviously it doesn't say those words, but we recognise that this up here that I've highlighted is completed square form. And if we go about completing the square for what's up there, if we halve the coefficient of x, we get x minus 5 in brackets squared, and obviously that's going to make plus 25 at the end, and we don't want plus 25, we want 7. So to get from 25 back to 7, we have to take away 18. Let's have a look, minus 18, and just always double check that, don't rush it. 18 and 7 makes 25, so yes, minus 18. And it says now that is going to equal 0. So obviously that's the first part there. We've written it in the form that it was asking for. So to solve that as an equation, we just need to set that equal to 0, as it says there. It says that it equals 0. Let's just highlight that. There we go. That equals 0. So if we go about solving this, let's get rid of that 25. The rest of this process is actually quite simple. So in order to get to the value of x here, we just need to move that 18 to the other side to start with. So if we add 18 to both sides, and then we can see what the next step is. So we would have x minus 5 in brackets squared, that's left on the left hand side, and that now equals 18. Now we need to get rid of that squared bracket, so we need to square root both sides. And if we square root both sides here, don't forget that when you square root something, there is a positive and a negative solution to that. For example, 25, the square root of 25 can be positive 5 and it can be negative 5. And that's where the introduction of this plus and minus comes in, which you probably recognise from the quadratic formula as well. So when we square root both sides, now that gets rid of that square bracket, and we have x minus 5 is equal to plus and minus the square root of 18. There we go. So we're almost getting there. We've got that plus and minus in, and now we just need to get rid of that minus 5 and get x on its own. So if I add 5 to both sides now, there we go, plus 5 to both sides, and just take note that obviously the question wants this 5, this number in front of the root there, to go at the start. So if I put that in the front, and I'm going to bring it up here, we would get x is equal to 5 plus and minus the square root of 18. There we go. Now we're almost done. We have actually got our solutions there, okay? But it says to give your answer in the form a plus and minus b root 2. And that's because the surd there, the root 18, simplifies. So root 18, if we have a think, what square numbers go into that? 9 goes into it. So root 18 can also be written as the square root of 9 multiplied by the square root of 2. The square root of 9 is 3, so that is 3 root 2. There we go. So root 18 can also be written as 3 root 2. So our solution, getting it in the right form there, is x is equal to 5 plus and minus 3 root 2. There we go. And that is now in the format that the question's asking for, and we have got our solutions there in surd form. Okay, so that's how we're going to go about completing the square and solving these equations by using this process. And let's have a look at one that is slightly harder, and I'll show you why actually they're not actually any harder than the one we've just done on the screen here. So this question, we've got 2x squared at the start, okay, and obviously when we're completing the square here, we do have to take that into account, and we are going to first complete the square. It then says hence solve the equation, so just like the last one, and giving your answer in the form a plus b root 3, where a and b are integers. So let's start with completing the square. So we'll take out that factor of 2, so we have 2 lots of x squared minus 4x minus 8, okay, and then let's complete the square for what's inside. I'm going to swap colours like I've done before, there we go. So half that coefficient of x, and we have x minus 2 in brackets squared, and that's going to make plus 4 at the end, and we want minus 8, so we're going to have to subtract 12 there to make that balance out. Reintroducing that 2, let's see what we get. There we go, reintroduce the 2, and we have 2 lots of x minus 2 squared minus 24. Now for the second part of this question here, it says hence solve the equation. So we're going to do exactly the same thing. We're going to set it equal to 0. So if I set this equal to 0, and I'll do it separately up here, we have 2 lots of x minus 2 squared minus 24 equals 0. Now it's completely up to you in terms of the steps that you do here, but there's a couple of things that we can get rid of from the start. Either we can get rid of this 2 at the start, we could divide everything by 2, or we can add this 24 over to the other side. Now personally, I just like to add the 24 over first, but it's completely up to you in terms of which order that you do it. I'll show you why it doesn't really matter. But if I add the 24 over, let's have a look. We get 2 lots of x minus 2 squared equals 24. Now at this point I'm going to divide by 2, so that's going to turn that 24 into a 12. Now you could have divided by 2 at the start, it wouldn't obviously affect the 0 over here, so 0 would still be 0, but you've just got to remember if you do divide by that number you also have to divide the 24 by 2 because that's going to become 12 on the other side, and you've got to make sure you divide everything by 2 on that left hand side of the equal sign. So personally I just like to add it over first, I feel like it just helps you not to forget to also divide that by 2 as well. So if we go about dividing by 2 now, we'll get x minus 2 squared equals 12, and then it's exactly the same as the last question. Now we can square root both sides and we get x minus 2 equals plus and minus the square root of 12, and then we can add that 2 over to finish it off, and if we add the 2 over, let's see, we're running out of space a little bit here, but we get x equals 2 plus and minus the square root of 12. Obviously we do just need to have a look, and let's just bring this up here, we do need to have a look at obviously writing it in the form it wants, and it wants it as b root 3. So we need to think obviously about that root there, and that is root 12, and how does that simplify? Well, let's have a look. Root 12, the square number that goes into that is 4, so we can write that as the square root of 4 times by the square root of 3, and the square root of 4 is 2, so that's 2 root 3. So finishing this off then, we can write it in the form it's asking for, and that is that x equals 2 plus and minus 2 root 3, and there is our final answer, writing it in that third form that it's asking for in this question. So before we finish, I've got a couple of these for you to have a go at, and they are going to be our last questions, so here they are. Okay, so here's your last 2 questions to finish this off, so have a go at these, pause the video there, and we'll go over the answers in a sec. Okay, so for the first one then, we've got writing this quadratic up here in completed square form. So if we do that then, I'm going to put it up here, we get halve the coefficient of x, and we get x plus 5 squared, that's going to make 25. We want to get back to minus 3, so we're going to have to take away 28. And there it is in completed square form. When we set that equal to 0 then, we get x plus 5 squared minus 28 equals 0. We don't have to worry about dividing by anything because we've got no coefficient in front of the bracket there. So let's add the 28 over. So we get x plus 5 squared equals 28. Square rooting both sides then, let's have a look. We get x plus 5 equals plus and minus the square root of 28. And then subtracting that 5 over, we get x equals minus 5 plus and minus the square root of 28. And obviously we just need to have a look back at the question. The question asked us obviously to put this in the form a plus and minus b root 7. So root 28 must simplify, and root 28 is root 4 times root 7. There you go, root 4 times root 7, which is 2 root 7. So writing our final answer then, we get x equals negative 5 plus and minus 2 root 7. And there is our final answer, and we've got that in the format that the question was asking for. Okay, on to our next one then. So for this next one, we do have a slightly harder quadratic to obviously complete the square for here, because we've got to take out that factor of 2. So if we go about doing that then, we get 2 lots of x squared minus 8x minus 4. And completing the square for that, we get 2 lots of, there we go, let's just put it straight in, x minus 4 squared, that makes plus 16, we want minus 4, so minus 20. There we go, and then reintroducing that 2, let's see what we get. We get 2 lots of x minus 4 squared minus 40. And again, always just go back and check there. We've divided that quadratic by 2, which gives us the negative 4, half the coefficient of x. Halving that then in completed square form, we got our minus 4, which is going to give us the minus 8 we're looking for, and obviously that makes 16, and we want to get back to negative 4, so 16 to negative 4 is negative 20, and that all suits us fine. So that is definitely in our completed square form that we're looking for, and now obviously we just need to set that equal to 0 and get our solution. So if we set that equal to 0, and let's do that up here, there we go, first thing I can do is add the 40 over. So we have 2 lots of x minus 4 squared equals 40. Dividing both sides by 2 will give us 20. So we have x minus 4 squared equals 20. Square root both sides and add the 4 over. I'll try and do it in one step just so we can got the space here. and we'll get x equals 4 plus and minus the square root of 20. Okay, so I've skipped a step there, I've square rooted the 20 and added the 4 over. And then we just need to think about that root 20 and obviously simplifying that. Obviously, because the question's asked us to put it in the form a plus b root 5. So root 20 simplifies to root 4 root 5. There you go, root 4 times root 5, which is 2 root 5. So we just need to put 2 root 5 in there instead. So we have x is equal to 4 plus and minus, what was it, 2 root 5. There we go. And there is our final answer. And that is it solved in third form in the format that it's asking for in this question. So there we go, that's how we go about using completing the square to solve quadratics and leaving our answer in third form. And obviously that also shows you a little bit to do with the quadratic formula as to where that plus and minus square root comes in as well. So there we go. Obviously don't forget to check out the video on surds. Don't forget to check out, obviously, well, if you're already at the end here, hopefully you've already checked out the video on completing the square. And also don't forget to check out obviously the quadratic formula, which is another way of solving quadratics as well. But there we go, that's the end of the video. Hopefully you found it useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.